In this example, you are given the area of this land, which is 6,000 feet squared, and also the information given is the one of the side length is x, and the diagonal length is 10 feet longer than that, which means it's x plus 10. So if I want to find this side, let me call it b. I know this looks like a Pythagorean theorem, so I could say x plus 10 the whole squared is equal to x squared plus b squared. So from here I can write b squared is equal to x plus 10 the whole squared minus x squared, or b would be equal to just square root of x plus 10 the whole squared minus x squared. Okay, so the area is the area of this rectangle is x times b, or I can write in terms of x as a of x equals x times square root of x plus 10 the whole square minus x squared. This area is given here in this problem as 6,000 feet squared. So now I'm going to take this equation and try to rewrite it. So x times square root of x plus 10 the whole squared minus x squared is 6,000. So square both sides, that will get me, the radical can get eliminated, square both sides. So the left hand side would be this quantity squared, and the right hand side would be that quantity squared. So this is going to make my left x squared times x plus 10 the whole squared minus x squared. Okay. The radical disappears and is equal to 636, and then 1 2 3 1 2 3. Now I'm going to use the distributive property. X squared times x squared plus 20x plus 100 minus x squared is equal to, okay, and I'll combine any like terms in the parentheses, which would be, it will eliminate the x squared, so I'm ending up with 20x plus 100 in the parentheses. Okay, distribute this, x squared 20x to the power of 3 plus 100x squared, and I'm bringing this over, minus 36, 1 2 3 5 6. Okay, equal to 0. So factor out a 20, that will make this an x cubed plus 5x squared minus, if I divide this big huge number by 20, I will get 18, 3, 4, 5. So this, if I divide both sides by 20, I can do that, right? Like to eliminate the 20 will disappear, and I'm having what is in the parentheses, x cubed plus 5x squared minus, if I have to put parentheses on, commas on the proper spots. Okay. 1 to 3, 1 to 3. 1 2 3 1 2 3. Okay, so the next step is to solve this equation. So now I have to solve this equation like I've done for the other problems in this section, listing the potential zeros, which is going to be so much because of this huge number, right? And then finding the first zero, and and then using remainder theorem to find the first zero, use synthetic division to break it into a second degree polynomial, and so on. But this is a word problem, and one thing I know for sure is my x is going to be positive, like, and I need to know what the x value would be, right here, the positive x value. So what I'm going to do, directly I'm going to go to my calculator and I'm going to graph this. Okay, I can do it the long way too, but it's going to take some time. So I would graph this x to the power of 3 plus 5x squared minus 18, 1, 2, 3, 4, 5. Okay. Now I know for sure I can keep my window x minimum 0 and y minimum 0 because I'm looking only at quadrant 1. And now here the x maximum and y maximum, I'm just going to keep 20. And I may not see the graph, but just I'm going to start it at 20. I'm going to hit graph. Okay, so this is telling the graph is there, but I cannot see it. So I'm going to go zoom fit, and then I can change my window as needed. Zoom fit. It's still working. I see that little circle circulating on top. Okay, I don't think it's going to end. So I think this, so the calculator is finding it difficult to find it. So I'm going to quit it. Let me start with managing my window again. So give me 1 second. Okay, I'm going to go to y equals, when I have the graph. I'm going to change the window. Now you see that, you know, the calculator was trying to get a very huge number, but it's looking in the negative direction, so I don't want that. So 0, I'm going to put a big number here, like say probably say 100 or 150 maybe. And then for you know, I think this, because this is a huge number, so how about like 500? And then on here I'm going to use like say 150. Now again I'm guessing these numbers, okay, depending on this huge number. 10 squared 100, so maybe a little above that, like that's how I'm looking for. Oh, okay, so I see that there is a point here and I'm looking for what this x value is. So let me go ahead and find that x value. Second calc, 0, left bound, so I'm in the negative direction. Y is negative, enter. Y positive, enter, enter again, and that's giving me my x value is 120. So x is equal to 120, so this length is going to be 120 feet. Okay, and that's what I'm looking for, the you know, the dimensions of the land, and they want the biggest number to go here, so 120 feet will go. Okay, so I have to find the other one to decide which one is big, right? Okay, since I know this, now to find b, I can use this equation. B is equal to square root of x plus 10 the whole squared minus x squared. So b would be square root of 120 plus 10 the whole squared minus 120 squared. So I can use my calculator. 130 squared minus 120 squared. So let me use my calculator here. 130 squared minus 120 squared, and then I need to take the square root of that number. That's going to be 50. So this is square root of 2500 is equal to 50 feet. So I was right that b is the shortest length, which is 50 feet, and x is the largest value, which is 120 feet. So X is the length of the rectangle and B is the width of the rectangle. So I'll say 120 feet and 50 feet. Okay, so in this problem you saw that, though it was a third degree polynomial, I did not go through the process that I would do in a regular problem. Again, because it's a word problem, I know that I can keep my x minimum and y minimum to be positive. So I kept it as 0 and 0 so that I'm looking at quadrant 1. And then the x max and y max is just kind of, I'm guessing bigger numbers because of these huge numbers. So because we know that the area itself is 6,000 feet squared. So, as we square, the numbers are bigger, and that's why the window in which I saw this graph here is x minimum is 0, x maximum I kept it 150, y minimum 0, y max I kept it at 500, and x scale as 1 and y scale as 1. I did not, change those. Now I saw that 120 was the, from there, or, I can even go here to the table, and this table, hold on, let me just start at negative 19, so that will be clear. Positive 19. Delete. Okay, now if I go to the table, I will be able to see my x value too, which is the x-intercept where the y coordinate is 0, which is 120. And that's how I'm getting this point. I can do it using my calculator table, or I can even go back and use the second calc feature to find it.